by using properties of determinants in exercise 8 to 14, show that this determinant is equal to this determinant, okay, this value. Okay, and how are we supposed to use the properties in this one? Let's see the way in which we can handle this one. So left hand side, and mind you one more thing, that the questions which will be following means the question starting from this one and a few more will be very important, because the values of these determinants are something that you should memorize for easy calculations in future, right? So 1a square, 1b b square, 1c c square. If you see this determinant, the value is a minus b times b minus c times c minus a. Similarly, 1a a cube, if you see something of that sort, then value will be something different. If you have 1a bc, 1b ca, 1c ab, then the value is exactly same once again. And how do we obtain those values? Will be see exactly that. Let's see. In the LHS, you have 1a a square, 1b b square, 1c c square. This is the determinant that we have, right? That's the determinant that we have. What can we do in this one? What we can observe is there are three ones in this particular column. So let's replace R1 by R1 minus R2, and we can also replace R2 by R2 minus R3. Okay, and on replacing this, the LHS becomes equal to what? This will be 1 minus 1, which is 0. This is a minus b. This will become a square minus b square. Then you have R2 minus R3, which will become 0, b minus c, b square minus c square, and 1c c square. This is what you have. Right? This is what you have. Observe carefully. In a square minus b square, you have a minus b and a plus b. Yes, I can take out a minus b common in this complete row. This will give me a minus b. And similarly, in b square minus c square, you have a b plus c and b minus c. I can take out a b minus c common from here, and what will remain is 0, 0, 1 over here. Then you have a minus b, b minus c, which I have moved out. So there will be 1, 1 and c remaining over here. A minus b has gone, a plus b will remain, b plus c will remain, and c square. A plus b, b plus c and c square, that will remain. And now it is very easy to expand. We can expand along this first column, and what we get is 1 times this minus this. What is that? B plus c minus a minus b is what you get. That's all. Yes, that's all. B and b will get cancelled. This is a minus b, b minus c and c minus a, which is the RHS. That's the complete proof of this one. You also need to remember this one, right? Okay, we'll memorize this. Yes, we'll memorize this once you have proved this one. Right. Let's move on to the next question. 1a a cube, 1b b cube, 1c c cube is a minus b, b minus c, c minus a, and another factor over here, that is a plus b plus c. Let's memorize this one as well. But first, proof. What's the proof? Let's take a look at the proof. In the LHS, you have a determinant which looks complicated. 1a, a power 3, 1b, b power 3, 1c, c power 3. But you may have gathered some idea from the just previous question, that since there are 1, 1, 1 over here, what we can do is we can subtract these ones, right? So C1 can be replaced by C1 minus C2, and C2 can be replaced by C2 minus C3 simultaneously, right? We can apply this transformation to get 1 minus 1 is 0, a minus b over here, and a cube minus b cube over here. Yes. Then you have 1 minus 1, 0, b minus c over here, and b cube minus c cube over here. Then you have a 1c and c power 3 over here. That's what you have. From the first column, you can take out a minus b common, and if you observe, what is a cube minus b cube equal to? Let's recall. A cube minus b cube is equal to, factorize it, a minus b and a square plus ab plus b square is what you get. Can you observe that? Yes. So on taking out common, what you observe is a minus b, b minus c will come out common, and the remaining determinant will be equal to 0, 1, and then you have a square plus ab plus b square. Then you have 0, 1 and b cube minus c cube, which is b square plus bc plus c square. Okay, and then you have a 1c, c power 3. Yes, this is what you have. Is that okay? Yes, that's okay. What else? The next thing that I can do is I can simply expand along this first row. Is there any other way to simplify it further? If you observe, there's a square, AB, B square, BC, C square. At max, you can subtract these two and you can get rid of one B square. But that's the end of it. That's the end of it. That's all that you can do. Oh, but you have a 1, 1. Let's subtract them together. We can subtract them, but that is what we'll be doing when we expand along this row. This minus this, AD minus BC. So let's get that done. A minus B times B minus C, and expand along this will be AD minus BC, and this will be equal to B square plus BC plus C square. This minus this, A square AB B square. This is what you will get. This is what you will get. So A minus B is okay, B minus C is okay. And what will remain over here is, observe, B square will get cancelled, right? What else? What else? BC plus C square, no. BC and AB are important, right? Let's focus on that. BC and AB, you can take out a B common. What you get is C minus A. BC and AB, BC minus AB. Plus C square minus A square remains, right? This is what remains. Do you observe that there's a C plus A and C minus A over here? There's a C minus A over here. We can take out C minus A common. C minus A will come out common, and what will remain is B plus, this will be a C plus A. And do you observe that, yes, this is equal to the RHS. That's a complete proof of this question over here. Is that all? Yes. We'll memorize this. Yes, we'll memorize this. Let's move on to the next one after this.